Hey friends, welcome back to my physics channel. So today we're going to discuss about the dot product, that vector multiplication method. So when we are multiplying any two numbers, let's say 3 and 5, we can either write 3.5 or we are putting the symbol as 3 cross 5. Both way they will give you the same result, that is 15. But here in physics, when we say dot product and we say cross product, they both have completely different meanings. So here dot product, that's why we put only dot sign. Let's find out what does that mean. So dot products A dot B simply means the magnitude of A times magnitude of B times the cosine of the angle between them. Now, if A vector and B vector are inclined by an angle theta, so where this length is, let's putting the perpendicular from A on the vector V. Now you can say that from cosine rule, this length of this triangle is A cosine theta, because cosine theta is adjacent time the hypotenuse. So if I write this adjacent time as the projection at the hypotenuse as the length of vector A, that I'm writing the magnitude of A, we can say that the projection of A on vector B is A cosine theta. Now let's find out the dot product of two vectors, that is A and B. If I put A dot B, that is the magnitude of A dot product with magnitude of B, it simply means the length of A cosine theta, that is the projection of A on vector B, times the magnitude of B. That we can simply write, because this is a length, that means this just a number like 5 centimeter, 3 centimeter, or 10 centimeters. So these are just the numbers. So when you multiply this number, they will simply give you a number, that then the cosine of the angles between the two vectors. And remember, the dot product of the two vectors, they will always give you a number. That means it's simply a scalar. It simply gives you a number. Okay, now let's understand why this is necessary to know the dot product. So why we trying to find out the dot product. Now let's see the A dot B, that gives you the A length time B length time cosine of theta. If you see the angle between them, the theta is equals to 0, then the dot product you will get a positive AV value. So when you get positive AV value, that means the theta is acute. That means if this is the unit circle, the angles will be lie between here in this the first quadrant. So that means they are more aligned to each other. That means the lesser the value of theta, they are more aligned to each other, they are more along each other's. Now what happened when theta is like pi radian or 180 degree? If you see the unit circle, you will find that the two angles are more out of like they are more out of alignments, they are not aligned with each other. So when the angle is more and more, the alignment is less, and the value A dot B, you will get obviously the negative of the length of A dot B. Now what happens when theta is pi by 2 radian or 90 degree? So when the two vectors are perpendicular to each other, obviously cos 90 is 0. So you will get the dot product of the two vectors as 0. That means the two vectors are perpendicular to each other. So when you need to find out the alignment about the vectors by seeing the angles, you can just simply say that whether the vectors are more aligned or not. You don't need to have to go for the calculation. The more application I think we can found when you will go for the force, work, power, and electric power, so there the more when more application will come across and more concept will be clear. Now let's see what are the some properties we can get from this dot product. So dot products, they follow commutative rules. Let this A dot product B is same as B dot product A. Now this is the example. Let's say A is 3i cap plus 2j cap, then vector B is I cap minus j cap. Sometimes I miss the arrow on the vectors, I'm sorry about that. So when you pound A dot B, you will see that is the value is same as B dot A. Here we found this in a different format. We are going to discuss how we get the result in this way. Now associative property. So what we mean by associative, that is a scalar multiplied with dot product of two vectors A dot B, that is same as C A times dot products B. That means C simply scalarly multiplied with the vector A, and the dot product of B will give you the same result. And it also follow the distributive law. That means A dot product B plus C is same as A dot B plus A dot C. Now come to the next one. So the component format. So this is the one way of finding the dot product of the two vectors, and this is the another way. When the vectors are represented in the component notation, that is like in I, J, K unit vectors, along the unit vectors, there is another way we can find out the dot products, that is A dot B. So that put the values of A in unit vector notation, dot products B, the total the vector B in unit vector notations. Now you can just apply one of these properties there. Let's say the distributive properties. A dot B is same as A dot B plus A dot C. Now what we can do simply distribute all these terms. The first term dot product with all this term, then plus the second term, with the dot product with this term, plus the G component of A vector dot product with the bxi cap byj cap plus bzk cap. Now again you have to go through this distributive property, then you got these 9 terms. Now look at this ax, ay, or bx, by, these are all scalars. These are just the numbers like 2, 3, 6, 7. This can be anything. So when you are multiplying a number and number, you will just get a number. All these ax, bx, ay, bx, ag, bx, they will simply give you numbers. Now the problem is with the vectors. I, j, these are all unit vectors. So we have to find out what is the value of this dot product of this unit vector. So if these are the unit vectors, the value is having 1 along each direction, x, y, and z direction. The value will be 1, and the vectors along itself, the angle will be 0. J along j, the vectors makes 0 angle, but when I with j with k, or k with I, or k with j, they always makes 90 degree to each others. So when we put I dot I, j dot j, or k dot k, that means unit vector dot product with the same unit vector, you will always give you the value 1, because cosine of 0 angle is 1. So I dot I or j dot j will be, or k dot k will be 1 times 1 cosine of 0, so that will gives you the value 1. So every time the terms with the same unit vector will give you the value 1, so you will get only the term ax bx plus ay by plus ag bg. Now all other terms, that is j with I, k with I, or I with j, that means they are making 90 degree with each other. So that means a dot b, I dot j, or k dot I, they will get 1 dot 1, and cosine of 90 degree, that means cosine of 90 is 0. So all this term will go get 0. So finally you will left with a dot b is ax bx plus ay by plus az bz. That means dot product of two vectors when given in the component format, you will get only the multiplication of x component of both vectors, multiplication of y component of both vectors, and the multiplication of z component of both vectors. From this also you can say that the a dot b will give you just a simply a scalar numbers. So that's why we say that dot product is a scalar. It will give you just a number, not vectors. So which formula are we going to use? That depends what is given to you. If the angle is given and the magnitude or the length of the vectors are given, it's always easy to find out a dot b in this format. And if the components are given, it's always easy to find out the dot product with this method. So, okay, so if you like the video, please subscribe. Thanks for watching.